Alright, today we're looking at graphs of logarithms. Let's just start with a simple example and work our way up. Let's say I have y is equal to log base 2 of x, and I want to graph this function. Interestingly enough, you simply do not graph this function to graph this function. Get it? No, no, really. What we do is we graph the sister function right here, the inverse function. If I was to go ahead and make this into an inverse function, or take the inverse of this right here, what I would do right here, convert this to exponential form. I will drop the base, drop the log and take the base to the other side, and that will leave me with 2 to the y power is equals to x. Right here. So again, what I was trying to say, but not very well, is drop the log and take the base over. That will give me an equivalent expression, but in exponential form. The reason why we want to use this equivalent expression is that it's much easier to work with exponents because we can choose numbers more easily that don't result in fractions or really large calculations. And so you have your x and you have your y values right here. And what you simply do is you choose your y values instead of your x. And so you have -3, -2, -1, 0, 1, 2, and 3. And you take each of these and you plug them in for y into this function right here. So for instance, 2 to the third power is going to be 8. And then 4, then 2, then 1, then 1/2, then 1/4, then 1/8. There we go. Again, you can double check this right here. Log base 2 of 8 right here. Well. I know that this is log base 2 of 2 to the third power. And so this does in fact evaluate to 3. But we skipped all of these steps by simply working with the exponential form and using the y's as our starting point because I'm taking 2 to the y power. Now if I was to graph this function, so let's right here, 1 way out here, then 2, 3, 4, 5. Will I get to 8? No, I won't get to 8. Well, the reason why I have to do this right here is because I'm going to need a half. See, right here, x to the half. I'm going to need a quarter, and I'm going to need an eighth. 1, 2, 3. 1, 2, 3. And I got to plot these points and graph this function. So -1/8, -3, 1/8, comma -3, 1/4, comma -2, 1/2, comma -1. I have my x-intercept at 1, 0, then 2, 1, then 4, 2, then 8, 3, but I can't get there. Oh, that's alright. And you get a graph that looks like this. Again, we have 5 key properties that we need to learn and understand. The first is the domain. The domain is 0 to infinity. Then it's the range. The range is -infinity to infinity. Well, if you remember, for exponential functions, these two things have been switched. But we would have expected that because inverse functions, the domain and the range is always switch places. And so that's why the domain is no longer all real numbers, but instead there's only positive numbers. And remember, we also discussed this when evaluating logarithms. Notice right here, there's nothing over here. Undefined. This is undefined world over here. Undefined. There's nothing over here. And so therefore logs only take numbers that are greater than 0. Okay, let's not live in an undefined world, shall we? Then this graph is clearly increasing. And this is due to the base. Right here, this is because the base is greater than 1. As you will see in a second, when the base is a fraction, you actually get a graph that's decreasing. This is actually something that's true in both sets, equations and exponentials, logarithms and exponential functions. It helps when trying to learn about these two things to remember what they have in what they have in similar and what they have in different. Exponential functions have a y-intercept. Obviously, logarithms have an x-intercept. X-intercept at 1, 0. Oh man, I missed the x-intercept. Should go right through that. It should go right to that point right there. And last but not least, exponential functions have a horizontal asymptote. So logarithmic functions will have a vertical asymptote, VA of x equals 0. Alright. So again, everything gets switched out. Domain and range switch places. Y-intercept becomes an x-intercept. Horizontal asymptote becomes vertical asymptote. Only the increasing decreasing holds true to form. Let's get an example of one that's decreasing. I had log base 2 right here, so let's try right here. Oh, right. Last thing I want to point out right here is that logs can be negative. When you plug a fraction into a log of base greater than 1, you get a negative answer. Interesting, yeah. So let's try graphing this one right here. Say log base 3 of x. So y equals log base 3 of x. Again, to make the table of values for this function, I first convert this thing to exponential form. Drop the log and take the base to the other side. I get 3 to the y will give me the value of x. Making my little table of values, x and y. Again, I will choose my y values, plug those in, then go from there. Well, 3 squared is 9, 3 to the first is 3, 3 to the 0 is 1, 3 to the negative 1, that's reciprocal, 3 to the negative 2, reciprocal and square, so that's 1 over 9. So again, I create the same basic table of values, same basic graph structure. So I'm going to give myself some room. 1, 2, 3, 4, 5, 6. Will I get to 9? 7? No, I'm not going to get 9 again. Oh man. And I will need 1, 2, negative 1, negative 2. And I'm plotting points. Now, oh man, it's the wrong example. I needed to do 1/3. So I gotta go back and redo a little bit of this. Oh man. So, well, I guess you got some good practice. So this is going to be a 1/3 right here. And then all of these will switch places. 1/3 squared will be 1/9. Then 1/3, then 1, then 3, because 1/3 flipped is 3, 9, and then I plot me some points. So, 1, this right here will be a 1/3, and then this right here will be a 1/9. So at 1/9, the answer is 2. At 1/3, the answer is 1. At 1, the answer is 0. At 2, at 3, the answer is negative 1. And then at 9, way off yonder, the answer is going to be negative 2. So the graph looks like this. Off you go. Again, notice right here that when I have a base that is between 0 and 1, i.e. a proper fraction, to get a negative answer, I got to plug in a whole number. So that notion got flipped on its head. If I plug in a number that's greater than 1 I get a negative answer into this logarithm. So what are my properties? Well, I already know my domain and my range because they've been flipped. So it's going to be 0 to infinity. Again, no negative numbers, no 0 for logarithms. And my range is still going to be negative infinity to positive infinity. The graph is now decreasing, and that's because the base is a proper fraction between 0 and 1. The x-intercept is 1 comma 0, and the vertical asymptote is at x equals 0. That's it. Notice that all the properties are the same except this one right here, when you're comparing this graph to this graph. And the difference is obviously is in the base. Also, notice that if you compare that to their exponential counterpart, then everything has been flipped. Domain and range have switched places. Instead of having a y-intercept, I now have an x-intercept. Instead of having a horizontal asymptote, I have a vertical asymptote. Again, these help you manage the two in terms of you have less information to remember if you remember one and use that to help you remember the other one. You should always try and minimize the amount of information that you are trying to learn. Alright, let's look at the basic shifts. So let's go with the shift up, down, left, right. Let's go. Let's say I have y is equals to log base 2 of x plus 3 right here. This is a shift up 3. Well, the base 2 tells me I have an increasing log, and so my basic log function will look like this. Yes, and my dashes are missing. And this number clearly right here is 1. If I take this log and then lift it up 3 units, I will have a log that looks like this. Looks basically the same, but now it is higher. My domain will stay the same, 0 to infinity, because the graph did not get shifted left or right, so the domain doesn't stay the same. The range will always be all real numbers. That's one of those nice facts about logarithmic functions. That's your range right here. It is still increasing. Did not change. And the vertical asymptote, VA, will still be at x equals 0. Therefore, just like before we either got 3 changes or 1 change, the only change we're going to get right here is the x-intercept. Well, the x-intercept we need to calculate, and so let's go to our working column. We know when we're looking at the x-intercept, we said y equals 0, right? Remember this back in the day? And so I make y equals 0 is equals to log base 2 of x plus 3. I subtract 3 on both sides. And so I have negative 3 is equal to log base 2 of x. And does anybody know what to do right here? Yeah, that's right. You want to convert this to exponential form. Drop the log, take the base to the other side. X is equals to 2 raised to the negative 3, which is 1 over 2 to the third power. Remember, negative power is not a minus sign, means flip. 1/2 times 1/2 times 1/2 is 1/8. And so your x-intercept is 1/8, 0. Again, it's the only one of the 5 properties that will change. As you'll see in a moment, when I'm shifting the graph left or right, then you have a lot more properties changing. A lot more properties saying, hello, what's up, yo? There we go. Again, you have to go ahead and memorize and work through some of these examples to help you get better understanding. So let's say I have y is equals to log base 1/3 of, and then I have x plus 2. This is a shift to the left 2 units of the decreasing graph. And so I go down this way, I go across this way, and so I have 1, 2 right here, negative 2. Oh, the original graph, decreasing graph, looks like this. I shift that graph over, I will get a graph 2 units over. I'll get a graph that looks like this. It looks basically the same as the other graph, but it's a little bit further away, just a little bit. The vertical asymptote used to be here. It's now been shifted over 2 units, and so the vertical asymptote will now be right here. The x-intercept used to be at 0, 1, at 1, 0. Since it moved over 2 units, 1, 2, it will now be at negative 1, 0. So, with that in mind, again, my domain does not change. Oh, actually, my domain has changed. It's no longer from 0. Because I can plug in with negative 1, for example, and get an answer. My domain will now be from negative 2 to infinity. It got moved over, shifted over 2 units. My range will never change. The graph is still decreasing. The x-intercept, again, by counting, we got that the x-intercept was negative 1, 0. And then your VA, your vertical asymptote, is at x equals negative 2. So right here we see 1, 2, 3 factors changing when we shift the graph left or right. The last thing we look at is flipping the graph. If you make the graph upside down over the x-axis, or you flip the graph over the y-axis, how does that change the properties of our graph? Y is equals to negative log base 3 of x. This right here is a reflection. Can you remember which axis? Tick tock, tick tock. It's the reflection over the x-axis. And again, because the base is 3, I have an increasing graph. And so, this right here is my increasing logarithm. If I reflect it over the x-axis, the graph I will get will look the same but go the opposite way. So my properties, domain remains unchanged, range remains unchanged. It's not decreasing, that's a change. My x-intercept stays the same. In all of this you can see from the picture. X-intercept's right here. And my vertical asymptote stays the same. So when I reflect the graph in the x-axis, only one of the 5 properties change. And that is that it used to be increasing, now it's decreasing. The last kind of change we can have in our graph is if we have something like this, y is equals to log base, let's go with a fractional base, let's go with 1/4 of negative x. This is a reflection over the y-axis of the decreasing log. And so, well, I'm going to need some more space. My regular decreasing log just looks like this. Just come on down. You're the next contestant on The Math is Right. This right here is 1. If I reflect this lovely thing over the y-axis, I will get this graph right here. Woohoo! This point right here clearly must be negative 1. And so my domain has now totally switched. It used to be 0 to infinity. My domain is now negative infinity to 0. Of course, my range will never change. The graph used to be decreasing. Now the graph is increasing. My x-intercept used to be 1, 0. It's now going to be negative 1, 0. And my HA, that's the wrong kind of graph. My VA is going to be x equals 0. So that remains unchanged. So when I have a reflection over the y-axis, three properties change. The domain, where the graph is increasing or decreasing, and the x-intercept. Again, these things can be gleaned by quietly and properly graphing the linear transformed form of the graph. Right? Practice hard.